Hi guys, and welcome to this other video. I hope you guys are doing great. So today in our series of video dedicated to practical labs on FortiGate, or let's say getting practical knowledge on FortiGate firewall. So today we are going to talk about the topic of FortiGate SD-WAN. So during this video, we are going to cover these objectives. So we'll see what is SD-WAN, so how it works. We'll see concrete example of use cases. Then we'll talk about SD-WAN prerequisites. We'll also talk about SD-WAN components. Then we'll also mention deployment steps. Then we'll finish as usual with a practical case, practical scenario. So talking about the practical scenario, this is going to be the topology of or the diagram that we are going to use. So on this diagram, you can see I have a FortiGate device where I also have two ISP. So one is Roger and the other one is Rogers and the other one is Bell. So one Rogers is connected to port 1, while Bell is connected on the second one interface. So what we are going to do during this lab is to configure SD-WAN on the FortiGate firewall, and so that we can steer traffic, we can direct traffic either on one of these FortiGate devices, and we'll put each we'll redirect users traffic. So traffic that will be generated by these endpoints here, we'll redirect the traffic either going through through Rogers or through Bell, and we'll see also how to put each of the ISP link as a backup for the other one. So we'll also see how to redirect critical traffic or depending on the type of traffic that we will be getting on our endpoints. So for this diagram, I've prepared the following activities, so task 1 and task 2. But before I jump into the explanation of task 1 and task 2 of the details of these tasks, let me take a few minutes to quickly explain some key concepts of FortiGate SD-WAN technology. So what is SD-WAN? As you all know, SD-WAN is a software-defined or SD-WAN, or also known as SD-WAN, is software-defined wide area network. So this is a virtual network architecture that you can use, that uses software to manage and control your network traffic across wide area, right? So how does it work? So let's see, for example, on this image, you can see that from this image, for example, you have one data center, and you have many branch, I would say branch offices. So from this data center, you can see here that we have multiple links, right? Fiber link, 4G link, broadband, and MPLS. So the purpose of SD-WAN is to control the egress traffic that goes from this data center to each branch offices intelligently using one of the links that are actually connected on the data center, right? So this will use intelligent traffic steering. So the intelligent traffic steering here will lead to help monitor the network condition in real time. So also dynamically direct traffic over the best available path. So the purpose also of SD-WAN is to intelligently redirect traffic to the best available path, also ensuring that critical applications like voice and video are performing well, or you redirect those type of traffics to the link that is that has a better performance. That's how SD-WAN, the software part of SD-WAN, is going to work intelligently to steer traffic intelligently. And the benefits of using SD-WAN is this would let you to get effective WAN use and also reduce costs, right? So this is it for SD-WAN. This is how SD-WAN works. So this software-defined wide area network. The software part will intelligently redirect or direct traffic based on the criticality of that traffic. So the better link will be chosen to redirect critical traffic. So that's it for SD-WAN, and all of this will be configured on the FortiGate device, and there will be some like performance SLAs that are going to be configured to determine which of the link at a given time is the best link. So we'll see how to set up all of those. We'll see how to put in place all those settings in the next minute. So talking about use cases, so I've just prepared two common use cases here. So the first scenario here is a company that has one headquarter and branch offices. So here the headquarter might have like two ISP, as you can see from this image here. So you have ISP1 and ISP2. So the idea or the typical operation here is usually what people will do in this type of scenario is to use the best performing link for critical and sensitive traffic from the headquarter to branch offices, right? So between the two links, if this the link that if the ISP2, for example, in this scenario is the one having the best performance, you use this link to connect or to get access to critical and sensitive traffic. You will use this link to exchange sensitive information between headquarters or between offices, so the headquarter and the branch office. Then you will use the less performing link for general web browsing, right? General web browsing. And as I said, for each of the 40 of the links, each of the links or the ISP is going to work as a backup. So the second scenario here is a company that has only one headquarter and no branch offices. Here again, we still have two ISP. So in this case, as usual, you are going to use the best performing link to to get access to critical traffic and useful traffic for the company. So most of the time, this is going to be traffic such as voice over IP or access to Microsoft or 365 apps for the company. So you know most of the time in the companies now, most of the applications that are used by the company are either voice over IP by doing calls through Microsoft Teams, Zoom calls, or either users are accessing company data through Microsoft 365 applications, right? Or you will also use this best performing link to access company line of business app that are maybe hosted that are probably hosted in the cloud. Then you will use the ISP2, which is the less performing link. You will use this link for general web browsing, right? So these are the two scenario, the most commonly available scenario that you have on the field. So talking about prerequisites, so before you think of implementing SD-WAN on the FortiGate firewall, you need to make sure that the FortiOS that you are running has capabilities and functionality of SD-WAN enabled. So you have the right license, the proper license to run SD-WAN on your FortiGate firewall. You also need to have at least, as we said, at least two active WAN interfaces. So ideally, it should be one for better bandwidth. And so, as we said, at least two because you can have multiple ISP. So it can be more than two. So if you have more than two, it means you need more than two available links, one interfaces. So talking about firewall policies, you need to make sure that the available the WAN interfaces that will be taking part to the SD-WAN, those interfaces are not actually being used in any firewall policy. And also they are not being actually used or associated to any static route. So these are the prerequisites. You need to make sure the interfaces that you want to use for SD-WAN, those interfaces must not be part of any SD or any static route or any actual operating firewall policy. So that's it for prerequisites. So now talking about SD-WAN components. So implementing SD-WAN, as we already talked about the prerequisite in the previous slide. So now when it comes to implementing the SD-WAN, you need to understand that when implementing SD-WAN, you have what we call members. So members are we'll say they are the links coming from your ISP. So maybe if you have two links, you have here two members. Then talking about zone, zone is like a logical grouping of the members. As you can see from this image here, you have the SD-WAN zone. So it's the logical grouping of the members. Then you add the members in the zone. So as we said, you can have two or multiple members. Then now, as we talk of SD-WAN as being a software-defined way for your FortiGate device to steer traffic intelligently. So to steer traffic intelligently, we need performance SLAs that will configure on each member. So these performance SLA are going to check the health of each link or each member that is taking part of SD-WAN. So the health of each member here is based on the percentage of packet loss, the latency, and the jitter of the link. So based on the information that you will get for each of the SD-WAN members, that is how the SD-WAN is going to define or to decide which of the link is performing better, and based on that, he will know which traffic need to be redirected to that link. So this is how we are going to configure. This is how performance SLA works. So also now that you know about performance, now that you know about performance SLA, or when you've configured performance SLAs and you have information regarding each link, now you can create rules to redirect specific traffic to a specific link. So like you decide, for example, okay, if you have like three members and the second member or the link 2 is performing better, you can decide, for example, to redirect critical traffic to the best performing link. So you define rules here. The rules will be like, for example, you would say each communication that goes, maybe let's say from the internal network to maybe to social medias. Like if users have to access social media, you can define a rule that says communication from the internal network to the social media should pass through the less performing link, right? So you would not like to use the best performing link to access social media or general web browsing, right? So that's where we are going to define rules. So you will see that the rules here are different from firewall policies. So the other component here is firewall policy. So the rules here will be applied on the SD-WAN section, while the firewall rules will apply here on the firewall. So the rules here, it should be SD-WAN rules. So here we're talking about SD-WAN rules, and here we are talking of firewall policy. So firewall policy, as you already know, are the policies that will allow traffic from your local network to the internet, right? Going through the SD-WAN interface. So after configuring rules, you still need to allow traffic from your LAN to the internet, but this time going through the SD-WAN, right? So we'll see all of this in the next minute during the setup of this SD-WAN. So as I said, this is going to be the diagram. So these are the activities that we are going to perform. So as I said, task 1 is going to be setting up SD-WAN. So here, as we already explained the GNS3 diagram, I'll show it again in the next minute. So we are going connect on our FortiGate device. What we're going to do is to enable the SD-WAN feature, add new SD-WAN zone and members. Then we'll create a static route plus a firewall policy. We'll test connectivity on the client workstations. We also check traffic statistics on the SD-WAN members. Then we'll check the matching log of the firewall policy. Then also checking the firewall, the matching log is to see if traffic is being redirected on both links, right? So what we're also going to do, we're going to interrupt or disable one of the link, then check the logs again to see if traffic is being redirected now to one link. to the only link available. So we are going to do this with the default criteria of the SD-WAN. So on task 2 now is where we are going to define SLA performance and SD-WAN rules. So here in task 2, what we are going to do is to create performance SLAs. So creating performance SLAs, then after we'll analyze and adjust the value. So you know when you create the performance SLA, it will take some time to get the appropriate values that you are going to maintain on your FortiGate device. So this second subtask here is going to be where we're going to analyze and adjust the value of the packet loss, latency, and jitter. So thirdly, we are going to simulate the failover of one link, then adjust the settings regarding the link status. We also create SD-WAN rules to redirect. You see, for example, to redirect social media traffic to a specific link. We'll test the traffic on the client workstation, and we're also going to check the matching logs of the firewall. So let's jump directly to my GNS lab. Okay, so here's my GNS lab, as I said. So here we have Rogers. So Rogers is one of my ISP that I'm using, and Bell is the other one. Both are connected to the interfaces, as you can see here. Then here I'll have like a internal network that I'm going to create. So on the FortiGate firewall, I'm going to configure port 3. I'll configure a DHCP server on port 3 so that these devices here will get IP addresses, and from the firewall policy and rules that we are going to create, we'll see how to redirect the traffic that will be generated by this endpoints to either Bell or Rogers. So let's jump on our FortiGate device and let's proceed. So here I'm connected on my FortiGate device. So as I said, we have Bell and Rogers. So here on my port 3 is where I'm going to create a DHCP server, right? As I said, I'm creating a DHCP server here to address these devices. So here I'll give IP of, just creating this. I'll call this LAN. Yep. So here I'm going to enable DHCP server. First IP starting from 100. Okay. So that's all I need to do. So I don't really need to. Okay, maybe we can see enable administrative access here, but I don't think we are going to need it during this traffic, during this test or during this lab. So that is it for our DHCP server. So I'll hit OK. Okay, so normally we should start getting DHCP client if I start powering on these devices. So I'll just power on this. No, what did I do? So start. Okay. So now what we are going to do, let's go under network. So to start the settings, as we said, to start the settings here, we are going to go on network and jump under network here, and we'll go under SD-WAN. So here under SD-WAN, you will notice that by default on all FortiGate devices, there is this default zone that is called virtual WAN link, which is available by default, and you cannot remove or delete it from here, right? You can maybe use it as it is already available. You can probably use it, or if you want, you can create your own zone. So what we are going to do here, we are going to create our own zone. So I'll just hit here new zone. I'll call this test zone. Hit OK. So now we have a zone that we've created here. So what we are going to do next is to create our SD-WAN members. So here on SD-WAN members, what I'm going to do here, I'm going to select the two FortiGate devices, or the two ISP that I have here. So I'll start with Rogers, and when I'm creating the zone, I'm adding the zone directly to, I'm adding the SD-WAN member directly to a zone. So I'm selecting also the zone here directly. So all the information that are here, I don't need to change them. The gateway will be taken dynamically. Cost, I'll leave it by default, and priority by default. Then I'll just enable this. I'll hit OK. I need to add the second member. So the second member here is Bell. Zone here is zone test. So same thing, hit OK. So if now you can see that I have under my zone, my SD-WAN zone, I have my two FortiGate device, my two SD-WAN, or I would say my two ISP. So I have my two ISP here. You see a dynamic gateway that they have. You get here information about cost, bandwidth download and upload. Information about download and upload. So from here, what we are going to do next is to create static routes and one firewall policy. So what we are going to do here, we'll go on static route. No static route is available for now, so I'm going to do create. So I'm going to redirect all traffic to this interface. So the interface that I'm going to use here, instead of selecting a particular interface, I'm instead selecting here a zone. See, so because under this zone we have these two members, so we are redirecting traffic to go through this zone. So hit OK. Then now I'm going to create a firewall policy. So here, firewall policy, use new layout, create new. So all I'm going to do is just simply say port 3 to internet, right? Yeah, port 3 to internet. As I said here, our DHCP device, our DHCP is configured on port 3, so we are letting these devices to go to internet. So port 3 to internet. Incoming interface port 3, outgoing interface here now is going to be the zone, so the SD-WAN zone. So the source for now I'll go with all. So I'll just simply go with all, destination all also, and all services. So for the for the purpose of this video, we are just going to take everything all. And what else we can do here is just lock all the allowed traffic. We can keep, we can save all the logs about the allowed traffic. So from here, just hit OK. So here is our firewall policy. So what we are going to do next is to test connectivity on client workstation. So actually what I need to do is, first of all, I need to check on the interfaces to see if, okay, so the DHCP client is DHCP server is working fine, as we actually have three clients. So now I'm going to jump on the clients. Let's start with webtem 1. We'll just try to see if we have access to internet. Okay, you can see now that internet is working fine from here. Just creating random traffic like this. Okay, so you can see we have access on the end devices, right? We have access on end devices. So I guess the next task was to check logs or check traffic statistics on the SD-WAN members. So before, let me generate more traffic by connecting on the other endpoints, so that we just create more traffic before jumping on the SD-WAN to double check. So back here on our SD-WAN interface, you can see now that from here we can monitor information regarding bandwidth, volume, and sessions, right? So actually we can see that for bandwidth, for downloads, here you have information about download bandwidth and upload bandwidth, both for Bell, ISP, Bell, and Rogers, right? And you can also check here to see the volume of data transmitted by each of the ISP links, right? And here in the sessions, you will see that actually Rogers is carrying 136 sessions, while Bell is actually managing 19 sessions. And you can see information here about the download speed and upload speed for both links, right? So what else we need to do here is check the matching log of the firewall policy. Okay, so now let's jump on the firewall policy. So here we go under firewall policy. Then from here, we'll just right click and select show matching logs. So all we need to check from here is just to make sure that if I select traffic here, we can see that destination interface here, we see, for example, this is going through Rogers port 1, and you also get to see if there is any traffic going. There's a lot of traffic actually going through through my Rogers ISP, right? So probably because the Rogers ISP has a better bandwidth. So I'm just checking to see if I have any information related to Bell. Okay, so far, as you also saw in the sessions, you could see that in the sessions Rogers is managing most of the traffic, right? So now the next test is going to be to interrupt one of the, or disable one of the link and check to see if traffic is still going through the other link, right? So as we could observe, let me connect again from here. So as we could observe, you could see that most of the traffic is actually going through the Rogers link, right? So as you can see here, for example, on the sessions we have for Rogers, we have 272 sessions, while Bell is actually handling only 21 links, 21 sessions. So what we are going to do here actually is we are going to disable the Roger link, right? So here from our GNS3 here, what we are going to do is we are going to disconnect the link that goes to Rogers. So I'll simply select here. So we are simulating like there is an issue on the network, right? So now let's jump again on our FortiGate device here to see how traffic is actually being monitored. So let me refresh here. So when refreshing here, you will see now that actually Rogers is displaying red. So you can see now that Rogers is actually disconnected. So normally now all traffic that was generated or was managed by Rogers should be redirected directly now on Bell. So let's double check now under sessions. You will see now that under sessions, Bell is actually Rogers is actually having 12 sessions, while Bell is actually carrying like 28 sessions, right? Let's create like some traffic here again, then we'll monitor this again to see. So I'm just generating more traffic here. The purpose of this is just to make sure that actually the traffic is actually being redirected on the Bell interface or the Bell link, right? So let me refresh again here. Okay, so if I double check here, you see now that actually Bell is having 115 sessions, while Rogers still have the 11 session that was already available on Rogers, right? So you can see now that actually we still have access to internet. We are going through internet now. We have access to internet now, going through the Bell interface, right? Internet now we have access through the Bell interface, as from our GNS3 diagram here. The interface that goes to Rogers is actually down. So that's it. So I guess the last point here was to check again the logs for the firewall policy. Okay. So from here, we are going again here under firewall policies. So from here, we are going to again right click and show matching logs. So here, if I double click, you will see now that all traffic is going through port or through the Bell interface, right? All traffic is now going through the Bell interface. So every traffic that I'll select here, you will see now that all the traffic is being redirected to the Bell interface, right? So the SD-WAN is working fine. So guys, I guess this task 1 is now completed. Let's jump now on task 2, where we see how to define SLA performance, and based on the SLA performance that each link is going to display, we are going to create SD-WAN rules so that we can redirect specific traffic to a particular link based on the based on the SLA performance that we'll get. So let's jump directly on the FortiGate to continue with task 2.